All right, 9.2 chords. So for starting off, we need the definition of a chord. A chord is a segment with both endpoints, E, N, D, P, T, S, on the circle. And what I mean by on the circle, I mean on the edge of the circle. Within the realm of chords, you could say, well, a diameter is a special kind of chord, right? Kind of like how we say, well, a square is a special kind of rectangle. A diameter is a special kind of chord. So just in number one, I'm going to highlight some chords. This guy here is a chord because he touches the edge. But this guy also, the diameter, is a chord because he also touches the edge. Number two, well, this guy here would be a chord. And that's the only one listed in number two. All right. So, number one, find the length of the segment indicated. Round your answer to the nearest tenth if necessary. So we kind of have to look and see what all is in number one. We're trying to find x, and we're given 4. The dot here that looks like the center of the circle, that is the center of the circle. Well, it looks like x is a radius, and 4 is a radius, so x is going to be 4. Nice and easy. Number 2. Well, this is kind of different. If a chord forms a 90-degree angle with a radius, then the radius bisects. B-I-S-C-E-T-S, I think that's right, bisects the chord. Now that's written in words. If you look at the picture, you can probably just kind of see that. You can kind of convince yourself of it. This piece here is equal to this piece there, right? If you add those up, we have a chord, and then if I were to extend this line, that is a radius. So we have a chord and a radius. They made a 90-degree angle. So the chord is bisected. The chord is cut in half. So we could say, well, this piece here is equal to this piece there. So really quickly, I can say, well, x is 18. All right, number 3. So here's my x. How do we want to solve this? There's a couple different ways that I see to solve it. We know that this whole piece is a radius. We know that this over here is a radius. So I could say, well, this radius here is, what is 42.2? 42.2 divided by 2. Well, that's 21.1. So I could say, well, x plus 9.3 is 21.1. And I think that would be the easiest way to solve it. There's one other way that we could go about solving it. We could say, well, this piece here is 21.1. This piece here is 17.5 because the other piece is 17.5. And we have a right angle, so we could use the Pythagorean theorem. On some of them, you will have to use the Pythagorean theorem, but if you can avoid it, it would just be a lot faster for you. So I'm going to solve it using this green equation that I wrote. So I'll say, well, 21.1 minus 9.3, and I get x is 11.8. Number 4, Again, same scenario, only it's kind of flipped over above. I don't know how you can kind of see that. It's a little bit different. So again, we could say, well, this piece right here is 12.4. This right here is, I don't know, what is 28.6 divided by 2? That gives me 14.3. And then we have a leg there, and we could use the Pythagorean theorem. A little bit of a faster way to do it would be to say, well, this is a radius, this is a radius, so they have to add up to be the same thing. So 14.3 is x plus 7.1. So 14.3 minus 7.1 gives me 7.2 is x. So the issue here would be if they did not give you the 12.4, nope, excuse me, if they did not give you the diameter there, you might not be able to do that way. Or if they didn't give you this piece, I think that's the way that the problem will be. If they don't give you the 7.1, you'd end up having to use the Pythagorean theorem. Number 5. Oh, this one we're going to have to use the Pythagorean theorem. We've got a triangle here, and it is a right triangle, and we're not given enough information to be able to use the tricks that we've been using. So I'm going to say, well, I'll use a squared, b squared. So I'll say, well, x squared plus 11.8 squared is 22.2 squared. So x squared plus 11.8 squared is 139.24 equals 22.2 squared is 492.84. I'll subtract 139.24 from both sides, and I get, well, x squared is 353.6. And we don't need to worry about rationalizing. So I'm just going to type that in, and I'll say, well, x is 18.8. And remember how I said before that we really need to use a plus or minus here, right? Anytime you take a root, you're supposed to use a plus or minus. This again is going to kind of break that rule because we're talking about geometry. It doesn't really make sense to have a negative length. So whenever you take a root, you don't need to worry about using the negative version. And that's our answer. Number 6. Well, here's our x. We've got a right angle. We're going to end up using the Pythagorean theorem. But things are kind of wonky on here. We've got this piece here and this piece there. Let me not do that. I'll say, well, this piece and this piece are congruent. And you could also say that this piece and this piece is congruent. So down here I can write, well, 18.1 goes there. And now I have a right triangle. So I can say, well, x squared plus 18.1 squared is 20.9 squared. To make it easier for my calculator, I'm going to solve it without taking my squares. So I'm going to say, well, x squared is 20.9 squared minus 18.1 squared. Right, I just subtracted it to the other side. And then I'm going to write a big root so that I can type it all at once in my calculator. X equals the square root of 20.9 squared minus 18.1 squared. Right, and because I just solved it all and I have my x equals, I can just type that in my calculator one time. So big square root 20.9 squared minus 18.1 squared. And I press enter, and x is 10. We'll say 45. What was I supposed to round to? Round to nearest tenth. That's 1 decimal point. I guess this should be 10.4 then. All right, there's number 6. Moving on, number 7. Well, I think we're going to have to draw in some pieces on our own. So x is just this little piece out here. In order to use that, we'll need to know this piece here. Whenever we know the green piece and the orange piece, we can use them to add up and say that they're 12. In the meantime, we could draw in a radius here. That's going to be 12. So I'm going to introduce a new variable y, and now I can use Pythagorean theorem to find y. So I say, well, y squared plus 10.1 squared is 12 squared. I'm going to rearrange that and say, well, y equals square root of 12 squared minus 10.1 squared. So in my calculator, square root of 12 squared minus 10.1 squared, that gives me we'll say 6.5. So y is 6.5. So now I can find my x. So the whole piece is 12. So I can say, well, x plus y is 12. X plus 6.5 is 12. So x would have to be, I'm thinking that's 5.5. 5.5, yes. There we are. Now you could have, if you wanted to, I think this would have made the problem a little bit harder, you could have said, well, this here is 12 minus x. And instead of introducing the y, you would plug in 12 minus x into the Pythagorean theorem here. I think that makes the Pythagorean theorem a lot harder and it makes the problem just longer in general, but you are welcome to do that. Number 8. I think this is going to work just like number 7, except the radius is already drawn for us. So the radius is going to be half the diameter, so 25.2 divided by 2 will give me 12.6. I'm going to need to find this piece, I'll call it y, and the other piece is 11.5. So using Pythagorean theorem, I can say, well, y squared plus 11.5 squared is 12.6 squared. So y is the square root of 12.6 squared minus 11.5 squared. I type that all in my calculator. I say, well, square root of 12.6 squared minus 11.5 squared gives me y equals 5.1. I know that x plus y is 12.6, so x plus 5.1 is 12.6. And whenever I subtract there 12.6 minus 5.1, I get x is 7.5. All right, there we are.